Hey, welcome back. Previously, we created this pub/sub class that is capable of getting multiple running processes to communicate over channels. Let's now use this class to get multiple blockchains to interact with each other. Specifically, when one blockchain adds a new block, well, we want that blockchain node to publish its new version of the chain to the entire network. That way, all subscribed blockchain instances of the overall app will get that new blockchain data, and then they can decide whether or not the new chain is valid and whether or not they need to update their own chains. This will make sure all the blockchains are synchronized across the network and then establish a majority for what is the true blockchain array state. To begin, we're going to need to make some minor improvements to the pub/sub class, so make sure you're in pub/sub.js. And then we're going to remove all this debug code that we have at the end. And then we're going to replace this with a module.exports equals pub/sub, so that way other files can use this pub/sub class. Cool. The next thing we'll do is we're going to add a new blockchain channel to the overall channels map. So we're going to have a new key called blockchain, and the value for this is also going to be blockchain in all caps. All right, when one blockchain instance adds a new block, it's going to be their duty to broadcast their version of the blockchain over this blockchain channel. That way other nodes can decide whether or not the new data is valid and decide to update their chain based off of that. Therefore, the subscriber in this pub/sub class needs to also subscribe to the channel. We'll call this subscriber.subscribe of channels.blockchain in addition to the channel for the test. Cool. Notice though that we do have some code duplication. If we follow this pattern, well, every time we'd want to add a new channel, we'd have to call this subscriber.subscribe in the exact same way. We can be a little more programmatic with this and make a generic subscribe to channels function. So let's call subscribe to channels rather than our current subscribe lines. We'll call a function that we'll create in just a moment called subscribe to channels. All right, nice. And then the function itself will be after handle message. So we have that subscribe to channels function. And then what this is going to do is it's going to go over each channel in the channels map and then call subscribe on that channel. So let's get an array of all those channel values. So we'll use object.values on the channels array to get both the test and the blockchain channel within an array. And then for each of these, we can run a callback on each individual channel. So the callback function is going to have one parameter, which is the channel that we're mapping over. When it's one parameter, we don't need the pair of parentheses, so we can take that out. And let's call this.subscriber.subscribe, and we'll subscribe to the currently mapped over channel in the for each function. Cool. So this will take care of automatically subscribing to both the test and the blockchain channels, and whatever channel we add to the channels map for that matter. Okay, cool. Let's add one more helper method, a publish method. This will be a helper method that can be directly called on the pub/sub instance that will use a publisher's publish method to send a message over a designated channel. So let's make the signature to this an object that has a channel and a message. Cool. And then in this, we're going to call this.publisher.publish. We'll pass in the channel and the message. Now, even though the signature to the publish method is two arguments of a channel and a message, I still feel like it's better to have an object overall as a parameter to our own publish method. That way, the caller of this can designate more specifically and more verbosely that the channel is a specific channel and the message is a specific message. So that way you don't have to worry about things like order when you're calling this publish method. Cool. Now that we have this generic helper methods, the next step is to beef up this pub/sub class to work with a blockchain instance. Let's make it a new requirement to pass in a blockchain instance to the pub/sub constructor. Up at the top to the constructor, we're going to pass in a blockchain within an object. And then the very first new line of the constructor is going to be to call this.blockchain is equal to the incoming blockchain instance. So now every PubSub instance is going to have a local blockchain to it. Nice. Now, when it comes to blockchains interacting, there's two behaviors that we want to support. First is that we want the blockchain to be able to broadcast its chain. And second, we want the blockchain to try replacing its chain if it receives a valid blockchain message. All right, cool. Let's add the broadcast chain method to take care of the first behavior. And this doesn't have any arguments because we can reference the chain of the local blockchain instance. This is going to call the local this.publish method. And then we'll configure the channel, which in this case is going to be channels.blockchain, so that blockchain channel we just configured. And the message is going to be this.blockchain.chain. All right, great. However, there is a catch to this. This.blockchain.chain is an array, but we can only publish string messages over channels. Therefore, we need to call it json.stringify and wrap the whole blockchain.chain in a stringified form when we publish it on the blockchain network. All right, cool. That takes care of broadcasting chains. Finally, this PubSub class should properly handle blockchain messages. Therefore, we need to update something in the handle message method. Right now, it's not doing anything based on the channel, but let's update it to be able to replace a chain when it receives a blockchain message on the blockchain channel. To start, we should get the original value of the chain by parsing the sent message. We're going to make a parsed message constant that is the result of calling json.parse on the message string. Cool. And then if the fired channel is the blockchain channel, well, we'll call the replace chain function of the local blockchain. So let's check if the channel is equal to channels.blockchain. Well, then indeed we should call this.blockchain.replaceChain with that parsed message, which is an incoming chain. And thankfully, this replace chain method has been configured to only replace a chain if the parsed message in the broadcasted blockchain is a truly valid chain and a longer one. All right, awesome. With that, we've covered the two main behaviors for blockchains interacting: broadcasting a chain and replacing the chain if a longer and valid one is received as a message on the blockchain channel. Now the last step is to actually create an instance of this PubSub class in our main index.js file. So head to the main index.js file. We're going to make a local PubSub instance, so we need the PubSub class locally. Make a PubSub constant, and then this is the result of requiring the local PubSub class. After blockchain, we'll make our PubSub instance, which can be all lowercase. And it's a new instance of the PubSub class, and we're going to pass in the blockchain within an array. Cool. And now to test this, the idea is to broadcast the new chain to any subscribed node every time a new block is added to the chain. That means we should call pubsub.broadcastChain in our API/mine function after the new block has been added to the local blockchain. Now we'll add that soon, but we've coded quite a bit, so let's once again write some experimentation code before we write the existing code. After our PubSub instance declaration, let's make this experimentation code while we'll call pubsub.broadcastChain right away. However, let's do this after a delay of 1,000 milliseconds, so that way we can give everything some time to register to all the subscribed chains, etc. However, let's actually do this with a delay of 1,000 milliseconds, and this is going to allow our PubSub implementation to subscribe to all the channels asynchronously. So our delay is 1,000 milliseconds. All right, cool. So with that and all of these changes, once you have them all down, head to the command line, and then we're going to want to fire npm run dev in the CryptoChain project. So npm run dev. It'll start the Redis server, and if all goes well, a message will be received on the blockchain channel. Very cool. And the message is the entire original chain. We also get an extra message that the incoming chain cannot be longer. This is because the publisher in the PubSub is broadcasting to all subscribers on the blockchain channel, which even includes the local subscriber of that blockchain instance itself. But regardless, this doesn't have a significant effect since a blockchain's own chain is never longer than its current one anyway, but it's cool to see that working. Now, it would be great if we could fire npm run dev on a second instance, but you're going to find that there's a conflict. The address of 3000 is already used by the original blockchain instance. Therefore, our next step is going to be to configure our application to be able to start at a different address. That way we can have multiple local instances of the blockchain going at once, and then we can see these blockchain instances interacting. All right, let's do that next.